So let's look at the quanta for the decay of the T quark. And first we'll look at the electric charge. And if we look at the electric charge, we can see that for the generic D quark, we have minus 1/3 contributed by the anti-T rishon, and no charges are contributed by the anti-V rishons. And then, but we know that the electric charge of the T quark is actually 2/3. So if we look over here on the contribution of this flavored boson plus, we will see that there's an electric charge of 2/3 on the flavored V quark, prime V, and that there is a charge of 1/3 on the T rishon. And so together we have a electric charge of 1, which then combined with the generic D will give us the 2/3 that we must have for the T quark. And this particle-antiparticle pair contributes nothing to the charge. And we will see that we have just the opposite here for the antiparticle. Now, if we look at the emitted W particle, we will see that this pair of anti-T and T pair contribute 0 to the charge. And then we can see that the flavored V, which is down here, with the prime unflavored T, carry away the electric charge equaling 1. And this combination of flavored and unflavored D and V contribute nothing to the electric charge of the W particle. And then if we look at the resulting B quark, then we have the we have the generic D, and we have this prime neutral, so it has no electric charge, and we have this neutral scalar composed of the prime pairs of a V and anti-V. So let's take a look at the spin. And so the spin of the generic D initially is minus 1/2 because the spin on the anti-V's cancel, being plus and minus, and so the entire spin of the D is given by the anti-T. And then the spin, of course, on these scalar bosons is 0, and this particle-antiparticle pair is 0. And of course, we will find the same here, the opposite. And then if we look at the B, we can see that the spin on the D has been changed by an exchange of anti-T rishons. And so now we have the spin on the generic D is 1/2 given by this 1/2 anti-T rishon. And that will be the spin on the B because these other particle pairs are scalar. Now, though this exchange here created a spin -1 particle, which combines with the boson plus and to give us our W boson, our W plus boson, which must have a spin of 1. And so let's look now at the weak charge, which is associated with the spin charge. And we can see now that this was a generic D with a -1/2, and so a left-handed D quark in the standard model will have a -1/2 weak charge. As we can see, 1/3 plus 1/3 is 2/3, -2/3 plus 1/6 will give us -3/6, which is 1/2. But this D quark is transformed into a T quark, which is a left-handed D quark, and so the weak charge, instead of being -1/2, will be +1/2. And we can see this scalar boson here, boson plus, has a 2/3 plus 1/3, which will give us 1. And so the 1 combined with the -1/2 will give us a weak charge of 1/2, which will be the correct weak charge for a -1/2 T quark. And of course, this particle-antiparticle pair adds nothing to the weak charge. And we can see it would be exactly the same here, but opposite. Now, if we look at the B quark is going to be a spin 1/2 quark, so it should have no weak charge. And if we see here, the weak charge, if we add these charges up, we have 1/6 plus 1/6, which is 1/3, plus -1/3, which is 0. And then we also have the scalar neutral boson, providing no contribution to the weak charge, and likewise this neutral boson here is providing nothing, so that we have the correct weak charge of 0 for this 1/2 spin B quark. Since all particles will have, right-handed particles will have no weak charge. And then we can see that here, in the W boson, we will have a weak charge of -1/2 being carried away, actually not -1/2, but of +1/2 being carried away with the W plus boson, which provides, according to the rule, a hypercharge of -1, which is correct according to the standard model for the W plus boson. Okay, and so that we see that for the electric charge, spin, and weak charge, we have quanta consistent with the standard model. Next, we will check, in the next video, we will check the isotopic spin, flavor, and color.